Good morning students, welcome to a fresh session. In the previous classes we have been dealing with number system, right? So we are going to be continuing with the same chapter. In the previous class we have ended with the topic of rational numbers being infinite between two numbers, right? So what was the last thing that we studied in the previous class? We have studied that any two numbers, when we take any two numbers, there are infinitely many numbers between these two numbers, okay? So that is what we saw in the previous class, right? Now, in this class, we are going to learn that when two numbers are given to us, we can find as many rational numbers as we want between these two numbers, okay? So that is what we are going to study. So now, how to find out rational numbers between two given rational numbers? There are three steps involved, okay? So we are going to see the three steps by which we can find out the number, whatever number is given, of rational numbers between any two given numbers, okay? So let's see the steps. Now, step 1, look at the denominator. Step 2, check and make the denominators same. Step 3, multiply numerator and denominator by 10. Okay? So, when two numbers are given to us, what do we do first? We look at the denominator of the numbers. Okay? We first look at the denominator of the numbers. Now, what is the denominator and what is the numerator? Suppose our question is 3 by 5. Then we look at the numerator, which is 3, and the denominator, which is 5, okay? We don't need to look at the numerator. We only need to look at the denominator, right? So we look at the denominator first, okay? Now, why do we look at the denominator? We are going to check whether the denominators are both same or not, okay? Now, second step tells us to check and make the denominators same. Now, first we look at the denominator. If it is same, then we come to the third step. Okay? That is, we multiply the denominator and the numerator by 10. Okay? And if it is not same, then we make it same. And then we multiply the numerator and the denominator by 10. Okay? Now, let's take some examples to make this clear. Okay? Okay, so the first question, let's try to find out 4 rational numbers between 3 and 5. Now, we are going to try to find out 4 rational numbers between 3 and 5. Okay? So, what is the first step? The first step is to look at the numbers, right? The first step is to look at the numbers. What are the numbers? 3 and 5. Okay? So, here, we are going to start the solution. Right? So, how do we check? First, we check whether the denominators are same or not. So what are the given numbers? 3 and 5. Right? Yes. So here, given 3 and 5. Right? Now, this 3 can be written as 3 by 1. Right? Because any number can be written with 1 as its denominator, because 3 by 1 is what? 3 itself, right? Now, 5 can be written as 5 by 1. Why? The same reason, 5 by 1, right? So, 3 can be written as 3 by 1 and 5 can be written as 5 by 1. Now, when we look at these two numbers, we can see that the denominators are same, right? The denominators are same. What is the denominator? 1. 1 is the denominator. So, it's the same denominator, right? Now, what is the next step? If the denominator is same, then we go to the third step. What is the third step? The third step is to multiply the numerator and the denominator by 10. Okay? So we are going to multiply the numerator by 10 and the denominator by 10. Right? The same way we carry out here as well. What do? We multiply the numerator by 10 and we multiply the denominator by 10. Okay? So now look here. What are the numbers we got? We got 3 into 10, 30 by 1 into 10, 10. Right? Here we get 5 into 10, 50 by 1 into 10, 10. Right? So can you see the numbers we got? The numbers we got are 30 by 10 and 50 by 10. What are the numbers we got? 30 by 10 and 50 by 10. Right? So, now we have got 30 by 10 and 50 by 10. Now, looking at these two numbers, can you see that the denominators are still the same? Right? Yes. So, what were the numbers that we got before? Before we had 3 by 1 and 5 by 1. Now, look at here. 3 and 5. How many numbers, usual numbers without any decimal point, right? How many numbers can you find between 3 and 5? 3, 4, 5. So the number between 3 and 5 is 4, right? So only the number 4 is obtained between 3 and 5, right? But now, after doing all these steps, can you see that there is a huge difference between 3 and 50? Yes, 3, 30 and 50, right? So there is a huge difference between 30 and 50, right? So now, how many rational numbers should we find out? We should find out 4 rational numbers, right? So what is the step down here? Between. So since it is between, we cannot take this and this. We have to take the numbers between them, okay? So what do? We look at the numerator and we increase them, okay? So 30, next is 31 by 10. The denominator remains the same, okay? 31 by 10, 32 by 10, 33 by 10, 34 by 10. Why did we stop here? Because we need only 4 rational numbers. Because we need only 4 rational numbers. Okay? Now, can you see what are the steps we have followed? Okay? Let's see. The first step was what? What was the first step? First step was we looked at the numbers 3 and 5. We know that 3 was 3 by 1 and 5 was 5 by 1. We looked at the denominators. We found that the denominators are same, right? Now, when the denominators are same, what do? You multiply the numerator and denominator by 10, right? Right? So, what did we get? We get we get 30 by 10 and 50 by 10, right? So we can write, therefore, the 4 rational numbers between 3 and 5 are these 4 rational numbers. So what did we do? First we looked at the numbers, then we check their denominators. If the denominator is same, then we multiply the numerator and the denominator of both the numbers by 10. Then we find out the number 30 by 10, and 50 by 10, right? Now after finding out the numbers, we can see that 3 and 5 did not have much gap, but 30 and 50 has 20 number gap, right? If you see 30 and 50, there are 20 numbers between 30 and 50, which means we got a huge gap. Now we can take any number that lies between 30 and 50 as the numerator, okay? And the denominator remains the same, okay? And whatever number we get with that method is rational numbers lying between this number and this number, okay? So these are the steps involved, okay? Now, there are many methods to find out rational numbers between any two given numbers, okay? Now, I have simplified this method and come up with this method because this is the most simplest method and this is the method that you can use on any type of questions that come, okay? So we do not have to change our methods depending on the different questions, okay? So for every question that comes that is of this type, we can use this method, okay? Now, why did we do all these? Let me explain using some examples. Now, 1 and 2. Are these numbers rational numbers? 1 and 2. 1 and 2. Are these numbers rational numbers? Yes, they are rational numbers, right? Now look here, between 1 and 2, how many numbers can you find? Definitely, how many rational numbers can you find? Now, 1.5, is it a rational number? Yes, it is a rational number, right? Why? Because 1.5 can be written as 15 by 10, right? 10 because after the decimal point there is one number, right? So 10. If there were two numbers after the decimal point, we would write 100, right? So 15 by 10. That means we can write 1.5 in the form P by Q, where Q is not 0, according to the definition of rational numbers that we have seen in the previous classes, right? Now, look here. Now, sometimes the numbers are such that we cannot find any number between them, okay? So, for example, if the numbers that are given to you are 3 by 5 and 4 by 5, what do? When it was 3 and 4, you can find out any number between 3 and 4. Any rational number between 3 and 4. How do you find out? You can just put a point and write 3.1, 3.2, 3.3, 3.4, 3.5, right? 3.11, 3.12, 3.13, 3.14, etc., etc. You can find infinite amount of numbers between 3 and 4. We have seen this in the previous video, right? Now, likewise, there are infinitely many rational numbers between 3 by 5 and 4 by 5 as well, okay? Now, in order to find out these rational numbers, I have taught you the steps right now, right? Other than that, what can you do? You can also find the decimal expansion of these numbers and find the numbers between them as well. Like 5 3 by 5. What is 3 by 5? When you divide, you will get 0.6. Okay? And when you divide 4 by 5, you will get 0.8. So now, you have to find out 5 or 4 or 3 or 2, depending on the question, as many amount of rational numbers, as many number of rational numbers they have told us in the question, according to the question, right? You can find out any number between them, okay? But sometimes it is not possible to divide and find the decimal expansion. And in our text, we have been given a particular method to find out, okay? So it is always better to use the method that I have shown you, because that method applies for every question, for any type of question, okay? So now let's see another example. Suppose, question number 2. I need to find 4 rational numbers between 4 and 7. Okay? Let's make that method clearer by taking some more examples, right? So let's make those methods clearer. Now look at 4 and 7. What are we supposed to find? We are supposed to find 4 rational numbers between 4 and 7. So, solution. What are the numbers given? Given 4 and 7. Right? Now, following the same method, same steps that we have seen in the previous question, let's carry out the same method. 4 can be written as 4 by 1. 7 can be written as 7 by 1. Right? Yes. Now, check the denominator. Denominators are same. Right? What is the third step? Third step is to multiply the numerator and the denominator by 10. Right? So 4 into 10 by 1 into 10 and 7 into 10 by 1 into 10. Right? Now 4 into 10, 40. 1 into 10, 10. 7 into 10, 70. And 1 into 10, 10. Right? So now we have seen that the numbers are 40 by 10 and 70 by 10, which means 4 is equal to 40 by 10 itself, 7 is equal to 70 by 10 itself. Can you check that? 40 by 10. What is 40 by 10? If you cut, 10 ones are 10, 10 fours are 40. So 4 is same as 40 by 10, right? 7 is same as 70 by 10, right? So that means finding rational numbers between 4 and 7 is the same as finding rational numbers between 40 by 10 and 70 by 10. Okay? Now, how do we find? We look at the denominators, they're the same. We look at the numerators, 40 and 70. Before we had 4 and 7. We cannot find many numbers between 4 and 7, right? But at the same time, 40 and 70 we can find, right? So, what are the rational numbers? Therefore, I can write. Therefore, 4 rational numbers between 4 and 7 are 40 by 10. Between 4 and 7 are 40 by 10. So we take the next number. What is the next number? 41 by 10. Denominator remains the same. Numerator increases by 1. You can take any number in the numerator between 40 and 70, right? So let me take some other numbers as well. I can take 42 by 10, but instead of that, let me show you another example, which is, since it is 70, I can also take 60 by 10, right? 60 by 10? Yes. Now, 60 is less than 70, so I can take 60 by 10 as well, right? Now, another number, 65 by 10 I can take. Why? 65 less than 70. It lies between 40 and 70, so I can take that, right? Now next, I need 4 rational numbers, so I have got 3 already. Now can I take 72 by 10? Yes, I can take 72 by 10. Why? Because 72 lies between 40 and 70. Is that right? Please jog your memory. No. Look here, 72 is greater than 70. Can I take 72? No, I cannot take 72. Whatever number I take in the numerator should be between 40 and 70, right? So can I take 62? Yes. I can definitely take 62. Why? Because 62 lies between 40 and 70. Alright? So this is the method that you need to follow. Let's see another example. Find 5 rational numbers between 7 by 10 and 7 by 10 and 4 by 5. So, we are going to find 5 rational numbers between 7 by 10 and 4 by 5. Alright? So now let's look. Same steps. Do not look at the number and be confused. Okay? Let's find, okay, using the same steps. Every question will use the same steps. Alright? So step 1. What do we do? Here given. What are the numbers that are given? 7 by 10 and 4 by 5, right? Look at the denominators. Are they the same? No. The denominators are not the same. So, the second step. What is the second step? The second step is, if the denominators are not same, then to make it same, right? So, we are going to make the denominators same. How do we make the denominators same? Whenever you have two fractions, okay? Whenever you have 2 or more fractions, these are fractions, right? 7 out of 10, 4 out of 5, so these are fractions, right? Now if you do not know what are fractions, please go to your lower classes textbooks, please refer what are fractions, okay? And also you need to know how to find the LCM of 2 numbers, please refer to your lower classes and please study there as well, alright? LCM, every class 9 student, every class 8 student in fact should know what is, how to find out the LCM of the given numbers, okay? LCM means least common multiple, right? So you have to find that, alright? Now look here, whenever you have 2 fractions, whenever the denominators are not same, what do? You find the LCM of the denominators. You find the LCM of the denominators. How do I find the LCM? Look here, 10 and 5 are the denominators. So I write 10 and I write 5 in my rough space and I'm going to find the LCM. How do I find? I take the least number with which I can multiply these 2 numbers, right? With which I can divide these 2 numbers, right? Which is the multiple of 10 and 5, right? So 5 is the least number in whose tables we get 10 and 5 both, right? So 5. 5 twos are 10, 5 ones are 5, and then we take 2, 2 ones are 2, and 1 ones are 1. So what do? We just leave it like this. Why? Because we have got 1, 1 already, right? So this is how we find the LCM. Everyone knows that, right? Now look here. What is the LCM? So LCM is 5 into 2 into 1 into 1. We multiply all the numbers that we have got, right? So what is it? 5 into 2, 10. 10 into 1, 10. Again 10 into 1, 10. So our LCM is 10, right? So now, in these 2 fractions, since the denominators are not equal, what are we going to do? We are going to make the denominators equal. Now, how do we make the denominators equal? We look at the LCM. What is the LCM? 10. Which means we need to bring 10 in both the denominators. Okay? What do we need to do? First we need to look at the LCM. Alright? And what is the LCM? 10. Right? Now we look at the denominators 10 and 5. Right? Now we need to bring the LCM in the denominator. Okay. Now look here. In the first denominator, the LCM is already there. The LCM is already the denominator, right? But in the second denominator, it is 5, right? But it is 5. We need to make it 10, right? What do we need to make? We need to make it 10. What do? We know that when we multiply 5 by 2, we get 10, right? So what are we going to do the first step? 7 by 10 remains 7 by 10 itself. 4 by 5 is equal to 5 into 2. Why is that into 2? Because I know that LCM is 10. In order to make the denominators both 10, I need to do something, right? The first denominator is already 10. I don't need to do anything since it is already 10. But the second denominator is 5. I need to make it 10. What do I do in order to make it 10? I know that 5 into 2 is 10. So I multiply the 5 by 2 in order to make it 10. Okay? Where did this 10 come from? The LCM. We need to make it the LCM, right? Now, 5 into 2. Now, in a fraction, you know that whatever we do to the denominator, we need to do it to the numerator as well, so that the fraction will be balanced and there will be no changes, right? We cannot randomly add or subtract or multiply or divide any number to either the numerator or the denominator. Whatever we do to a fraction, it should be done equally, which means we need to do it to the numerator and to the denominator as well. So here, in 4 by 5, I have multiplied 2 to the denominator, right? Which means in order to make it balanced, I need to multiply 2 to the numerator as well, right? Now, 4 into 2. Why? Because 2 and 2, it will cut, right? 2 ones are 2, right? So they will cancel. And what will I have? 4 by 5. So 4 by 5 equal to 4 by 5. Is it equal? Yes, it is equal, right? So that is the reason why we multiply both the numerator and the denominator by 2. Okay, that is the reason why we need to do whatever we do to the denominator to the numerator as well. Okay? So we get 4 into 2, 5 into 2. Now 4 by 2 can be 4 by 5 can be written as 4 2s are 8, 5 2s are 10, right? So 8 by 10, right? That means, look, when we cut it by 2, will I get 4 by 5? Yes, 2 4s are 8, 2 5s are 10. So I get 4 by 5. That means 4 by 5 is the same as 8 by 10, right? So now, what are the numbers that I've got? I've got 7 by 10 and 4 by 5. Or 7 by 10 and 8 by 10, right? So, therefore, the numbers are 7 by 10 and 8 by 10. Instead of writing 4 by 5, we can write 8 by 10, right? So the numbers are 7 by 10 and 8 by 10, right? Now look here, check the denominators. Now is the denominator same? Yes, now the denominators are same, right? Now the denominators are same. So when the denominator becomes same, what do? Now we can follow the rest of the steps and we can find the rational numbers. So once we look at the numbers, what did we do up until now? First we look at the given numbers, right? Then we look at the denominators, right? Look at the denominators. Are they equal? No. It is one is 10 and one is 5, right? Now our main goal is to make the denominators same. How do we make the denominators same? We take the denominators LCM. We take the LCM of the denominators. What is the denominator? 10 and 5, right? So the LCM of 10 and 5 is 10, we found out, right? So which means we need to make the denominators 10. Both the denominators should be 10 because 10 is the LCM, right? Now for that, what do? I look at one of the denominators, it is already 10, I don't need to do anything, right? Now the second denominator is 5, I need to make it 10. So what do? 5 into 2 is 10, I know that, right? So I multiply the denominator by 2 in order to make it 10, right? But I know that in a fraction, when I multiply or subtract or add anything to the denominator, I need to do the same thing to the numerator, right? So that's the reason why I multiply the denominator by 2, then I multiply the numerator also by 2, right? So now doing this, I get 8 by 10, which means 4 by 5 is the same as 8 by 10, right? So finding out 5 rational numbers between 7 by 10 and 4 by 5 is the same as finding out 5 rational numbers between 7 by 10 and 8 by 10, right? So now look at, now the next step, what are we going to continue? We haven't found out the 5 rational numbers yet, right? So we have to find out. So what do? Now we check the numbers. We look at the denominators. The denominators are same. So we can go on to the third step. What was the third step? The third step was to multiply 10 to both the numerator and the denominator. So let's multiply. So now 7 into 10 by 10 into 10, and this can be written as 8 into 10 by 10 into 10, right? We multiplied 10 to both the numerator and the denominator, right? Now we get 70 by 100 and 80 by 100. Now you can see that there is 10 number gap between 70 and 80. So you can take any 5 rational numbers between 70 and 80. How? Same step. Therefore, 5 rational numbers between 70 by 100 and 80 by 100 are 71 by 100, can I take? Yes. 71 is in between 70 and 80, right? 72 by 100? Yes. 73 by 100? Yes. 74 by 100, and I can take any number, so why don't I take 79 by 100? Yes. Right? The numerator can be any number between 70 and 80, right? So, this is how you find rational numbers between two given numbers, okay? Now, keeping this in mind, we are going to see how to solve the questions of exercise 1.1, okay? So, we are going to solve all the questions of exercise 1.1, alright? For that, let's see the first question. The first question is 0 a rational number? Can you write it in the form of P by Q, where P and Q are integers and Q is not equal to 0? Okay, so they are asking us if 0 is a rational number or not. And if it is a rational number, we have to show that it can be written in the form of P by Q. So let's see, alright? So, solution of the first question of exercise 1.1. Okay, so we're going to do exercise 1.1, question number 1. Okay, so the question number 1, we are asking us, is 0 a rational number? Now, in the previous classes, in the explanations, we have seen that yes, 0 is a rational number, right? 0 is a rational number, right? Now, look at why. Yes, we can write yes, 0 is a rational number, right? In the second part, they are asking us, can you write it in the form P by Q, where P and Q are integers and Q is not equal to 0? Yes, definitely we can write it, right? So, yes, 0 can be written as 0 by 1, where 0 and 1 are both integers and 1 is not equal to 0, right? So that is our condition. This is a very simple question, right? That is our condition for rational number, right? Now how do we identify if it's a rational number or not? Any number that can be written as P by Q, where P and Q are both integers and Q is not 0 is a rational number, right? So 0 can be written as 0 by 1, definitely, right? Any number can be written as that number by 1, right? So 0 by 1, where we know 0 and 1 are both integers, right? We're studying the first class, and 1 is not equal to 0, definitely, right? So definitely, so this is our solution for the first question, okay? So now the second question. Second question. In the second question, they are telling us to find 6 rational numbers between 3 and 4. So how do we find? Given numbers are 3 and 4. First, what do we do? We write 3 as 3 by 1 and 4 as 4 by 1, right? According to the rule, right? Now, in the next step, what do we do? We look at the denominators. Are they the same? Yes, they are the same. So what do? We multiply the numerator and the denominator by 10, right? So what do we get? 30 and 30 by 10 and 40 by 10. So what can we write? Therefore, the 5 rational numbers between what? 30 by 10 and 40 by 10, 13 by 10 and 40 by 10 are, what are the 5 rational numbers? Let's see. What are the 5 rational numbers between 30 by 10 and 40 by 10? To get it? 30 by 10 and 40 by 10, right? So 30 and 40. What is the next number after 30? 31 by 10. Am I right? Yes. 32 by 10. Yes. 33 by 10. So, are these 5 numbers between 30 by 10 and 40 by 10? Definitely they are, according to the steps that we have studied, right? So we have done several questions of the same type, so it should not be confusing, right? So these are all the 5 rational numbers between 3 and 4. Make sure you follow all the 3 steps and do this, alright? So now we are going to look at the next question. Next question is to find 5 rational numbers. Okay, in this question we have to find 6 rational numbers. So one more rational number you can write, 36 by 10, right? So now, the next question, we need to find 5 rational numbers between 3 by 5 and 4 by 5, right? So what do we do? Third question. Exercise 1.1, question number 3. 5 rational numbers between 3 by 5 and 4 by 5, right? Between 3 by 5 and 4 by 5. So given their given numbers are we look at the given numbers. What are the steps? We look at the given numbers, right? And in these given numbers, what are the denominators? 5 and 5. Same denominator. What do? We multiply the denominator and the numerator by 10. do we get? 3 into 10, 30. 5 into 10, 50. 4 into 10, 40. 5 into 10, 50. Right? So 30 and 40, you can see there are 10 number difference. So definitely, easily you can find 5 rational numbers, right? So therefore, 5 rational numbers between 30 by 50 and 40 by 50 are, what are the 5 rational numbers? You can find any number. 31 after 30, 32 by 50, 33 by 50, 34 by 50, and 35 by 50. Right? Yes. So these are 5 rational numbers between 30 by 50 and 40 by 50. According to the rule that we have studied today, right? Several questions were done, so please make sure that you understood the questions and you try this out, okay? Next. Now, the next question, question number 4, has 3 parts. We have to state whether they are true or false or not, and we have to give reasons for our answers, right? So the first question is, every natural number is a whole number. Now, looking at this statement, every natural number is a whole number. Look at here. What are the natural numbers? Natural numbers are 1, 2, 3, etc. till infinity. Right? We've seen this in the first class and you already know it from your younger classes, right? Now, next whole numbers 0, 1, 2, 3, etc. infinity, right? So, can you see all the natural numbers are also whole numbers starting from 1 to infinity, right? The only number which is not a natural number is 0, right? All the natural numbers are whole numbers definitely. 1, 2, 3, etc. infinity are also there in whole numbers. 1, 2, 3, etc. infinity, right? So, we can see that every natural number is a whole number. So, this given statement is therefore true. What is true? The given statement is true. Every natural number is a whole number, right? Now, we need to give reason. What is the reason? Because natural number set is a subset of whole number set, right? Yes, natural number set is a subset of whole number set. Now look here. Every natural number 1, 2, 3, etc. infinity are whole numbers, or you can write in simple words. Because 1, 2, 3, etc. infinity are all whole numbers as well, right? That is the reason, right? 1, 2, 3, etc. infinity are all whole numbers as well, right? So that is the reason, okay? Now the second part, every integer is a whole number. Look here. Second part. Every integer is a whole number. So instead of natural number set, we take integer set. What is the integer set? Starts from minus infinity, continues on. Minus 2, minus 2, minus 1, 0, 1, 2, etc. till infinity, right? It goes till infinity, right? So now can you see? Every integer is a whole number. Now look here. All these numbers from 0 on to infinity are all whole numbers, right? But can you see that minus -1, -2, -3, etc. till minus infinity is not a part of whole number, right? Is not a part of the whole number set, right? Definitely. So from 0 to infinity, it is a part of whole numbers. It is a whole number, right? But all the negative numbers are not whole numbers, right? Whole numbers do not include negative numbers. So the given statement is wrong. Every integer is not a whole number, right? But every whole number is an integer, right? Think about that, okay? Every whole number is definitely an integer. 0 is an integer, 1 is an integer, 2 is an integer, likewise infinity is an integer, right? But -1, is it an integer? Is it a whole number? No. -2, is it a whole number? No. -3, is it a whole number? No. So the negative numbers are not part of the whole number set, right? So we can say therefore false. And what is the reason? Because -1, -2, -3, etc. minus infinity are not whole numbers. Are not whole numbers, right? So negative numbers are not whole numbers. So definitely every integer is not a whole number. Some integers are 1, 2, 3, etc. infinity are whole numbers. But every integer is not a whole number, right? Now the next question. Third part. Every rational number is a whole number. Third part. Right? So, what do we do? What is the whole number set? 0, 1, 2, etc. till infinity. Right? 0, 1, 2, etc. till infinity is a whole number set, right? Now, take a rational number. 2 by 5 is a rational number. By 5, is it a rational number? Yes, it is a rational number. And 2 by 5, once I solve, what do I get? 0.4. Once I divide, I'll get 0.4. 2 by 5 is 0.4, right? Now, can you look at the whole number set? 0, 1, 2, 3, 4, 5, 6. Can you see 0.4 anywhere? After 0, it's directly 1. It is not 0.4, right? 0 point does not come in whole number set, right? So that means every rational number is not a whole number, right? But some rational numbers are. Like for example, 3. Is it a rational number? Yes, it is a rational number. 3 is 3 by 1. So, P by Q form. That means 3 is a rational number. And 3, is it a whole number? Yes, 3 is a whole number. It comes after 2, right? But some numbers are not whole numbers. Some rational numbers are not whole numbers, okay? So, there are numbers which are rational numbers as well as whole numbers, but not all numbers, okay? So, every rational number, is it a whole number? No. We can find many examples where rational numbers are not whole numbers. For example, 2 by 5. It is a rational number, but it is 0.4, which is not a whole number, right? Likewise, I can find another example, 1 by 2, 0.5. Is it a rational number? Yes, it is a rational number, 1 by 2, right? But is it a whole number? No, it is not a whole number, right? At the same time, 5, is it a rational number? Yes. Is it a whole number? Yes, right? So we can find many examples which are rational numbers, which are whole numbers. Rational numbers, some rational numbers are whole numbers. But every rational number, is it a whole number? No, it is not a whole number, right? So, therefore, what is it? Therefore, our given statement is false. Right? So, what can we write? We can write 2 by 5 is a rational number, but not a whole number. Therefore, false. Right? Therefore, every rational number is not a whole number. Alright? So, we have done all the questions from exercise 1.1. We have covered a really good portion of this chapter. Okay? So, make sure that once you have watched all these 3 videos, all the things that I have explained, the exercise and everything is clear. And please note down the things that I have taught you, all the important things that I have taught you, and go on and revise again and again. Okay? Because in maths, if you don't revise something, you will forget, right? And there is no use of not knowing what I taught in the previous class and coming and watching this, right? Studying from this video. There is no use, right? So make sure that every video you have watched several times, you have revised and you have practiced whatever questions you have done in these videos, and then you go on to the exercises. Only then you will be able to do it without even looking at the question. You will know the answers. Why? Because you are well versed with whatever you have studied, right? So make sure that you have studied everything, and then you come to this video and you do the exercises along with me. Alright? So in the next class we will be going with the rest of the chapter. Okay? So thank you for watching, and please study properly. Okay? Constantly practice and study properly. Okay? Thank you.